All right, welcome back everybody for another episode of Business Calculus. Now we're on section 1.4, applications of functions to economics. So now we're getting to the business end of the class. And we want to introduce some terms that we're going to be using for the rest of the semester. So does it do that every time? Okay, it doesn't. Okay, good. All right, so we're going to talk about things like revenue, cost, profit, and things like things that business people are interested in. So let's talk about revenue first. There's a nice little formula for revenue. By the way, revenues, that's the amount that is coming in. That's the amount that you take in. And the formula is price times quantity. So for example, if you're selling t-shirts, you sell 12 of them for $10, then you just multiply that price and quantity together to get the amount that came in, which is $120. Normally, we think of this function as a function of the quantity that you sell. And we keep the price fixed. Okay, we vary the quantity normally. All right. Not always though. Not always though. Sometimes we think of it as a function of the price, but the way it's set up here at least, it's a function of the quantity. So in this case, if we're going to fix it at $10 a shirt, then our function is going to be 10 times Q. Right? It's a linear function. The slope is 10. That slope is called the marginal revenue. That is the amount that revenue increases by, as we increase Q by 1. That's how we define slope, right? The amount y changes as we change x by 1. Okay, so that is the marginal revenue. So keep that in mind. All right, so that's revenue. And now we can talk about the cost function. So the cost, so by the way, we usually use capital R for revenue, and we usually use capital C for cost. All right, logical. And that function has two parts. It has a fixed part and a variable part. So to produce t-shirts or whatever, you're going to need a facility, and you got to pay bills and stuff like that. So that's where the fixed cost comes in. That's like your overhead, your bills, and like you got to pay rent. The rent doesn't change no matter how many items you sell, right? So that's what fixed cost is. It's also the y-intercept of the function. The cost to produce each additional item, that's basically your materials cost. That's called the marginal cost. That's how much the cost function increases as we increase the quantity sold by 1. And together, the marginal cost times the amount that you sell is called the variable cost. All right, so that's what goes in this part of the function. Okay, it's a mouthful, but as an example, if you have $200 in overhead and it costs you $5 to make each t-shirt, your function is going to be 200 plus 5Q. That's your slope, that's your y-intercept. I feel a sneeze coming on. We'll see. All right, so that is cost. Now that we have revenue and costs, we can talk about the profit function. And it's very common to denote the profit function by a pi symbol, like this. And profit is like the net income, which you get by counting revenue as positive and costs as negative. So it's revenue minus cost. So now that we know what the revenue and cost function are, we know what they are. So we can just put them in here. And that's how we'll define our profit function, our net result. Positive part minus the negative part. Okay. Why don't they use capital P for profit? Well, they typically we use like capital P. We'll actually use it in the next section, I think, for like exponential functions, for like principal. They use capital P. And so like we can't use that, so we gotta use something else. We'll use pi. You might say, isn't pi 3.14159 2, 6, 5. Yeah, yeah, it is. But this isn't the same pi. This isn't the same pi. They didn't think that far ahead. And this is the convention. So that's what we got. All right. Anyways, in our example that we talked about, let's construct our profit function. So we constructed our revenue function, which was 10 times Q. That was $10 a shirt times the number of shirts that we sold. And our cost function was our overhead plus our variable cost. All right. So we have revenue minus cost. So we just put that in. And we have a minus sign here. Whenever you subtract a sum of two numbers, you need to distribute the negative to both of the numbers. So make sure you're not forgetting to subtract 5Q here instead of add it. It's very important. So keep that in mind. And then 10Q minus 5Q, we can combine those like terms on the outside to get 5Q. Negative 200 just comes straight down. So this is our profit function. Now in math, we're always interested in when functions are zero. Basically, well, most of the terms that we've introduced so far, and some that we still have yet to talk about, are when some function is zero. So we talked about zeros of functions, when the function is zero. We've kind of briefly mentioned maximums and minimums, which will turn out to be when the slope is zero, potentially. And we talked about inflection points, which is also when a function is zero, which we'll talk about later. And when this profit function is zero, we call that a break-even point, which makes sense. You break even. You sold enough to recoup your cost. Okay, so your profit is exactly zero. If you sell more than that, then you have a net positive profit, or you just say a profit. And if you sell less than that, then you have a loss, right? A negative profit. So anyways, to find this, you just set the profit function equal to 0 and solve for Q. So we'll add 200 on both sides, and then we will divide by 5 on both sides. And 200 divided by 5 is 40. And I'll write Q on this side so we can have room to put a little note here that what did we find? We found Q. What is Q? Q is the number of t-shirts. How do we measure the number of shirts? We measure it in shirts. So we put shirts. All right, so that's our break-even point. Does that make sense? Yeah? Okay. All right, so break-even point, we can visualize it in two ways. On a graph, in terms of a formula, you can set revenue equal to cost, or you can take the difference and set it equal to 0. All right, so there's two ways, but graphically, if you have the revenue function and you have the cost function, the break-even point will be where they cross. Okay, here is we lose money, over here is we gain money. Right, our revenue is higher than our cost. And notice that the profit is like this space between the revenue and the cost. That's how much more the revenue was than the cost. So the more space there is between these two lines, there's more profit, right? Because the difference between revenue and cost is greater. But when there's no space, there's no profit. There's also no loss. That is the break-even point. All right. We can also think of the break-even point as a 0 of the profit function. So remember, profit is the difference between revenue and cost. And when that is 0, we've broken even. When we graph that profit function that we wrote, it looks like this. And where it crosses the x-axis, that's the 0. And that's the break-even point. All right, so two ways to visualize the same thing. One is as an intersection, and one is as a 0, but it's the same concept. Okay, let's move on. So the last thing we need to talk about is supply and demand. Now, I'm not an economist. I don't know very much about economics, but I will do my best to explain the very basics and try not to get out of my breath. So, supply curve relates the price that manufacturers are willing to produce and sell a certain number of items. Okay, it's on the manufacturer side. Demand curve is on the consumer side. It's how much that consumers are willing to pay for Q items available. All right, now normally these are actually functions of price, but this graph, the classical supply and demand graph, has the x-axis being the quantity and the y-axis being the price. But usually it's actually, when we write it out in formulas, it's the other way. We actually think about varying the price and looking at what happens to the quantity. So for example, I think it's easiest to make sense of it like that. So as we increase the price, notice that consumers are willing to pay less. It's getting close to this y-axis. The quantity is going down, right? As we increase the price, what also happens is that suppliers are willing to produce more items because they're going to make more money, right? Okay. So that's basically what happens. We look at what happens as we increase y, what happens to the x. Okay, it's a very unusual thing for us. We don't do that often in this course, but that's that. All right, in this intersection is called the equilibrium point. Just making sure of something here. I always get break-even point and equilibrium point confused. So break-even point, that's when profit is 0. And equilibrium point is when supply equals demand. Not revenue equals cost, but supply equals demand. So the concepts of revenue and cost are similar to supply and demand. There's a relationship, but they're not the same thing. They're a little bit different. Okay, let's see an example of supply and demand. All right, suppose we're given functions that give us the supply and demand. All right, the supply as a function of the price. Remember we said that normally we think of supply as being a function of the price, and demand also being a function of the price. If we want to find the break-even, see, I did it again. If we want to find the equilibrium point, then we need to set these two functions equal to each other. We want to know when supply equals demand. So we'll literally just set 3p minus 50 equal to 100 minus 2p, like I did here. And then we will combine like terms, so I'll move the 2p over to the other side by adding 2p. And I will add 50 on both sides, and I will end up with this. Then I will divide by 5, and I will get that p equals 30. And then how do I know that dollars goes here? Well, I just look at what I found. I found a value of p. What was p? P was a price. How do we measure price? We measure it in dollars. So that's how I know to put a dollar sign there. And just as a little note here, that is the equilibrium price. You might also be asked for the equilibrium quantity. So that's the actual value of the function when you put in that price. So if we put in 30 for the supply function, 3 times 30, that's 90, minus 50 is 40. Also 100 minus 2 times 30, that's 100 minus 60, that's also 40. Okay, it doesn't matter which of these functions you plug in the 30 to, because they're the same at the equilibrium quantity. At the equilibrium price. That's how we've defined the equilibrium point. Supply equals demand at that point. So it doesn't matter which price you plug, which function you plug the price into. you'll get the same thing. 40. Oh, go back. How do I know it's 40? Oh, that's scary. It's right below items. Okay, how do I know it's items? Because I found a value of Q, which was quantity. How do I measure the number of items? In items. Okay, in items. All right. Whatever your item is. T-shirts, you know, I don't know, balloon animals, whatever you're selling. Okay. All right, so that will wrap it up for 1.4. And so have a good day. Good luck on your Wiley Plus, not WebAssign. Have a good day. Goodbye.